Okay, so now we're on chapter 1, section 3. And here we're getting into collecting sample data. And again, you always have your student outlines to follow along with the slides. Okay, a key concept here is the method used to collect sample data influences the quality of the statistical analysis. So how we collect data is, of course, going to be important, and how we can ultimately do statistical analysis to begin with. Why does the method matter? If sample data are not collected appropriately, data may not be useful at all, okay, even with statistical manipulation. So when we're collecting data, we want the data to be useful. And this concept we'll talk a lot about, this simple random sample. And I want to start getting used to what that means. Okay, so simple random sample, it's a subset of a statistical population in which each member of the subset has an equal opportunity of being chosen or selected. Okay, so it's random. It's intended to be an unbiased way of sampling. One example you can think of, if you have names of 25 employees, the simple random sample means that 25 employees being chosen out of a hat from a company of 250 employees, which would be the entire population. So if you are following a simple random sample, each of the 250 employees in the population has the same chance of being selected out of the hat. You can see how that would be a little bit less biased instead of let's pick that employee, etc. This other concept in 1.3 is the gold standard. So you might have heard of this before as sort of a superior way of doing something. So you're following the gold standard. Okay, so in statistics, it's randomization with a placebo or treatment groups, sometimes called the gold standard because it's so effective. So let's talk about this placebo treatment group example. Okay, so if we have participants, they're randomly placed into two groups. One group receives a treatment, the other a placebo, and a placebo is, it can be a number of materials. We think of it as a sugar pill. It doesn't contain the active ingredient of a drug, but the patient might think that they are receiving a drug with an active ingredient, but they're just taking a placebo, which would have no medicinal effect. Okay, so neither the patients nor the medical personnel involved know which treatments are real and which are fake. Okay, so again, we're trying to minimize the biases here with how we collect data, and this is how we describe the gold standard. And the drug placebo is just an example of our use of a gold standard. There's some basics of collecting data, and statistical methods are driven by the data we collect. How we collect the data, what data we're collecting, who are we collecting it from? All of these things are really important to take into consideration with our statistical studies. We can obtain data from two distinct sources, so observational studies and experiments, and we'll talk about each one of these. Okay, so an experiment, you've probably heard about this as a scientific experiment. We would apply some treatment and then proceed to observe its effects on the individual. So we're applying a treatment and then we see what happens. The individuals in experiments are called experimental units, and they're often called subjects when they're people, so the subject of a study. So this is one way we obtain data. The other, observational studies, we're observing and measuring specific characteristics without attempting to modify the individuals in any way. Okay, so it's sort of a hands-off. We're just watching what happens. More on observational studies. This example I don't love from your textbook. It seems a little morbid, but let's go into it. So observing and measuring specific characteristics without attempting to modify the individuals. Again, this is in the category of observational studies. So let's have this scenario. We observe past data to conclude that ice cream causes drownings. Again, not my favorite example, but we'll go with it. We're observing past data to conclude that ice cream causes drownings based on data showing that increases in ice cream sales are associated with increases in drownings. So the mistake here is to miss the lurking variable of temperature and the failure to see that as temperature increases, ice cream sales also increase because it could be summertime, and then drownings increase because more people are swimming in the summertime. Okay, so it's making this correlation that we shouldn't try to connect. Again, the same scenario. So we're applying some treatment now, and then we're proceeding to observe its effects. So this is a more hands-on way of obtaining data versus our observational studies. Okay, so with an experiment, the scenario again, Conduct an experiment with one group treated with ice cream while another group gets no ice cream. And we would see that the rate of drowning victims, again, a morbid example, is about the same in both groups. So ice cream consumption has absolutely no effect on drownings. Here, when comparing the two sources for obtaining data, the experiment version here is clearly better than an observational study. Why is this better? Well, in our observational study, we were not applying a treatment. We were just trying to observe data and correlate data that we should not be trying to correlate. Here with the experiment, we're applying a treatment, we have more control, then it turns out that we can get a conclusion that makes more sense here. So not always are experiments better than observational studies, but these are the two different ways that we can obtain data. And you can start to imagine different pros and cons of each. Again, with part of this experimental design, replication is the repetition of an experiment on more than one individual. Good use of replication requires sample sizes that are large enough so we can see effects of treatments. If we were doing a simple study and we only surveyed 2 students on FRC's campus, is that going to be enough to really tell us how the overall student body feels about a certain issue? Okay, so we want to use this idea of replication in our studies. So we are repeating the experiment on more than just 1 or 2 individuals. And we'll learn more about what a large enough sample means as we go on this semester. Okay, and also within this concept of experimental design, we have the idea of blinding. Okay, so blinding is a technique in which the subject doesn't know whether they are receiving a treatment or a placebo. They have no idea. So blinding is a way to get around the placebo effect, and the placebo effect occurs when an untreated subject reports improvement in symptoms. So I'm taking a sugar pill and I have a headache, for example. If I took the sugar pill, I think I'm taking medication. So in my mind, I'm sort of self-healing that headache. This is an example of a placebo effect. Within blinding, we have this concept of double blind, and this occurs at 2 levels. 1, the subject doesn't know whether they are receiving the treatment or the placebo. 2, the experimenter themselves does not know whether they are administering the treatment or a placebo. Okay, so that's a way to, again, try to reduce the biases that can occur when we're setting up a statistical study. Another concept here that's important is randomization. So this is used when subjects are assigned to different groups through a process of random selection. Okay, so again, we're trying to minimize biases, so we can use randomization to help with this. The logic is to use chance as a way to create 2 groups where both groups are similar to each other. We have a whole population and we randomly select subjects from that population. And then we hope that those 2 groups should be somewhat similar to each other. Okay, let's get into the types of observational studies. And remember what we talked about with observational studies, these observe and measure, but they do not modify, versus an experiment. Okay, so we have cross-sectional studies where data are observed, measured, and collected at one point in time, not over a period of time. Okay, this is still all in the category of observational studies. Retrospective or case control study. This is when data are collected from a past time period by going back in time through records, interviews, books, magazines, so on and so forth. Okay, so there's also perspective or longitudinal or cohort studies. This is when data are collected in the future from groups sharing common factors, and these groups can be called cohorts. For example, we might have a statistician that separates their subjects into non-smokers and smokers, and then they see what happens maybe 3 months down the road as far as lung disease, for example. Okay, so again, this concept of simple random sample, and I want you to read this definition a few times and read the section in your book, okay? So this is a sample of n subjects is selected in such a way that every possible sample of that same size n has the same chance of being chosen. So let's say we have an entire population. We have samples from that population. Each of those samples has the same likelihood of being chosen for the study. So another way to think about this, we have a subset of a statistical population in which each member of the subset has an equal opportunity of being chosen. One example of this is if we have a population and we have 250 employees. each of the members of the population has a random chance of being selected out of a hat, for example. So I also put this pictorial representation here. Think of it as individuals or samples have the same likelihood of being chosen from a population for a specific study. Another big takeaway I want you to keep in mind with this is that it's intended to be an unbiased representation of a group. Okay, so let's continue on with these different ways of sampling. So we have systematic sampling. So we select some starting point, then select every certain element in a population where k is an arbitrary positive integer. So let's look at this example to have it make a little more sense. So if we have a row of cars, we end up wanting to select every third car. Okay, so that's where that kth comes from. Just any positive integer. In this case, it's every third car. So 1, 2, 3, we select that one. 4, 5, 6, we select that one. And again, here's another pictorial representation of this kind of sampling. So systematic sampling. Okay, we also have convenient sampling. So this is using data that are very easy to get. So notice it's also stated as data are very easy to get, because remember that data is the plural form of the word datum. Convenience, it is what it sounds like. It's using data that are very easy to get a hold of. There's also stratified sampling. This is subdivide the population into at least 2 different groups or strata. So the subjects within the same subgroup share the same characteristics. So I put this picture here of a woman in front of strata that we think of as far as the study of rocks, because it does kind of relate to how we look at it in statistics. So after we've divided the population into at least 2 different subgroups or strata so that the subjects within the same groups share the same characteristics, then we draw a sample from each subgroup. So that's one other way to sample a population. So in this pictorial representation here, we have a green group. The green people are in one group, the blue people are in another group. These are 2 strata. Then we select a couple from the green and a couple from the blue to be representative of those strata. Another type of sampling here is cluster sampling. Divide the population area into sections or clusters, and then randomly select some of those clusters and choose all members from those selected clusters. So the example on the right, if we have a street map, we have divided this street map into different clusters, and then we're selecting clusters, and then we're choosing all the members from those selected clusters. The pictorial representation on the left is another way of envisioning that. There's also multi-stage sampling. So all this means is collecting data by using some combination of the basic sampling methods that we just went over. So in this picture, we have simple random sample, a systematic sample, stratified sample, and cluster sample, and then convenient sampling too, which is not pictured, but that's another one we went over. So in multi-stage sample design, the statisticians that are polling select a sample in different stages, and then each stage might use different methods of sampling. So it's sort of a hodgepodge of these sampling methods that we went over. So you can think of multi-stage sampling as a combination of the sampling methods that we went over, including convenient sampling again, so a combination of these 5 different sampling methods. Okay, what could possibly go wrong? Well, let's see. We have this idea of confounding. So this occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. So they went through the entire experimental design, but it turns out that the experimenter at the end is not able to distinguish between the effects of different factors. So we might not even be able to get good data when confounding happens. So to work around this, again, we just try to plan the best we can and set up the experiment so that confounding does not occur, so that we can actually get useful information from our statistical analysis or our data set. Okay, now we're going to talk about controlling effects of variables. Okay, so one way to do this is completely randomized experimental design. This is where we assign subjects to different treatment groups through a process of random selection. Okay, for example, use randomness to determine who gets the treatment and who gets the placebo. Again, trying to minimize our biases. We also have what's called randomized block design, and a block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. And again, the book does a good job at giving you additional explanation of these different terminology that we're going over. For example, we'll form blocks or groups of subjects with similar characteristics. Then we randomly assign treatments to the subjects within each block. Okay, so another way to control the effects of variables is this idea of matched pair design. So we can compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. One nice example of this is, say we have a pair of twins. So genetically, the twins will be very similar. So if we take one twin and they're using a certain brand of toothpaste, and we have the other twin that's using a different brand, and we compare the results this way. Okay, so we have a matched pair, and that helps us make conclusions about the two different toothpastes because we are assuming that the two twins will be pretty similar. There's also rigorously controlled design, carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. This is very tricky to do. It's not going to be a straightforward task where we sort of pick and choose the subjects we put into different treatment groups. Because of bias, we could actually be adding more confusion to our design than we were intending to do in the first place through this idea of rigorously controlled design. Okay, now we're going to talk about sampling errors. So keep in mind that no matter how well you plan and execute the sample collection process, there's likely to be some error in the results. Okay, that's just is the nature of statistical studies. When we're talking about sampling error, that's also called random sampling error. Okay, so that's important that we're including random in that term. So random sampling error. This occurs when the sample has been selected with a random method. So we're trying to reduce biases, but there's a discrepancy between a sample result and the true population result. So such an error comes about from chance sample fluctuations, and we can't really easily identify those. And as we're talking about this definition here of sampling error, which is the same thing as random sampling error, I want to remind you about the definitions of population versus sample. Okay, so this occurs when the sample has been selected with random method, but there is a discrepancy between the sample result, which is supposed to be representative of the population. There's a difference between the sample result and the true population. Now, these are two examples of sampling errors that are not due to just chance fluctuation. So we have a non-sampling error. A non-sampling error is the result of human error, which definitely happens, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents. That's human error on the subject end, not on the statistician's end. Forming biased conclusions or applying statistical methods that are not appropriate for the circumstances. So this is non-sampling error. You can think of as human error, either by the experimental designer or by the subjects. And another example of sampling errors that are not due to chance fluctuation are non-random sampling error. When we think about this, this is error that is a result of using a sampling method that is not random. Okay, such as using convenience samples. So I'm going to go out to campus and with social distancing, and I'm going to start asking random people just out of convenience. Okay, so I'm not getting a random sample of a population here. I'm just going out and doing what's easiest for me to collect data. Okay, so that is chapter 1, section 3. I do hope you're reading along in your textbook. There's some pretty nice figures in your textbook to look at to accompany these lectures. Again, I hope you're all taking care of yourselves. I know there can be a lot going on, getting used to all the classes and all the things that are happening. And it's even more unique to try to do this over distance education. So I hope you're keeping up with the recordings and your homeworks, and I look forward to talking to you all very soon.